So now let's use the same ideas to go through subtraction of fractions. The ideas are very similar and there isn't much more of theory to add, but we'll just talk about it very quickly. So you know again the idea of equivalent fractions. So for example, if the denominators are the same, then it's very easy to subtract because 5 6 minus 1 6 is just 4 6. That's very easy to see. And now you already know if you want to subtract 5 6 minus 2/3, you're going to use the idea of equivalent fractions and you want to convert this 3 into a 6. That means you have to multiply it by 2, which means you have to also multiply the numerator by 2, and the answer is going to be equal to 5 6 minus 4 6, which is going to be equal to 1 6. Okay, and now let's start to think of a harder problem that we did earlier. Let's say I want to figure out what is 5 6 minus 1/10. Now that's a harder problem. So now we have to make this conversion and somehow convert the 6 into a number and 10 into a number so that they're the same number. So let's look at multiples of 6. When I look at multiples of 6, I get, let's look at multiples of 6. I'm going to think of 6, 12, 18, 24, 30, 36, dot, dot, dot. If I look at multiples of 10, I'm going to look at 10, 20, 30, 40, so on and so forth. And luckily, here you go, I find a common multiple of 6 and 30. So please note that this is 6 5s are 30 and this is 10 3s are 30, right? So what that means is that I can write this as, so I have to multiply the 6 by 5. So I'm going to say this is going to be 6, but I'm going to multiply this by 5 so that I can convert the 6 into a 30. But then I also have to multiply the numerator by the same 5, because if I don't multiply the numerator by the same 5, the fraction will change. Okay, and then I have the subtraction, and then I have 1 over 10, and now I have to multiply the the denominator by 3, right? Because 10 3s are 30. So that means I have to multiply the numerator by 3 also. So then the question becomes 25 over 30 minus 3 over 30, which is equal to 22 over 30. And remember, as we can multiply, we can also divide a fraction by a numerator and denominator by the same number. So what I can do is I can divide the denominator by 2, which means I have to divide the numerator by 2 also, and get an answer which is equal to 11 over 15. Now remember, this division is nothing mysterious. So for example, if you have something like let's say 3 over 6, so I have 6 pieces, 1 2 3 4 5, so I have 6 pieces, so maybe I have 3 out of those 6 pieces, so this is 3 over 6. What I can do is I can combine the 3 small pieces. So let's get rid of the boundaries. So if I get rid of the boundaries, what happens is, by getting rid of the boundaries, I have this chocolate piece left, but apart from this one boundary here, I get rid of the boundary. So if I get rid of the boundary, which means I am actually dividing the denominator by 3, because I had 6 small pieces here, and now I'm only going to be left with 2 small pieces in red. So this is just going to be equal to 2, and I have one of those pieces. So I just have one of those pieces, so this is just going to be equal to 1 over 2. And you can see division and multiplication hold similar roles. So you can simplify this also. Now let's look at another problem of subtraction. Let's say I want to subtract 1 whole, so it's a mixed number, 1 whole 7 over 10 minus 5 over 6. Now there are various ways to do so. I really feel it's easiest to just convert it into an improper fraction. and work it out. So 1 whole 7 over 10 is exactly the same as 17 over 10 minus 5 over 6. You already know that how to convert this. You have to multiply this by 3, which means you have to multiply this by 3. You have to multiply this number by 5. That means you have to multiply this number by 5. So you get an answer which is equal to 17. 3's are 51. So you get 51 over 30 minus 25 over 30, which is equal to 26 over 30, which you can simplify to by dividing the numerator and denominator by 2 to 13 over 15. Okay, so hopefully this should all be clear, and I'll see you next time.